All right, time for 11.4 day 2. Today we are going to be focusing on writing equations of translated conics and determining the shape of a translated conic without graphing. We're actually going to start with determining the shape first, and then we're going to move on to writing the equation. So, your greatest nightmares have returned. We are going to be looking at writing the equation in standard form, deciding what kind of conic section is based on the equation. In order to do that, we have this long polynomial here. We need to complete the square. And we're going to do it twice in the same equation because we have to do it with the x variables and the y variables to end up with some kind of x minus h squared over something plus or minus y minus k squared over something equal to 1. So here's what we're going to do. We're going to kind of reorder the equation so x's are grouped together and y's are grouped together and constants are on the right-hand side of the equal sign. So x's, let's do first, kind of see where we're at. So 4x squared minus 8x plus 5y squared plus 30y. And then we subtract that 29 from both sides. We get negative 29. Now here's what we're going to do. We have to essentially keep the x's together, complete the square there, keep the y's together, complete the square there, and then just make sure whatever we are adding to complete the square for both of those, that we are adding that same thing to keep it balanced to the other side. So first let's start with the x's. So first you can see there's a coefficient of x squared. You're going to want to factor that out. So we're going to take 4 times x squared minus, not 8x, 2x, plus some sort of, plus the b over 2 squared. So we're going to be adding, this is going to be our b value, negative 2 over 2 squared. Okay, so that's how we're completing the square for the x's. And then for the y's, we're going to have to factor out the 5. So 5 times y squared plus 6y plus 6 over 2 squared equals negative 29. Okay, now you have to be careful when we're adding here. We're going to add this negative 2 over 2 squared, which would just be 1, but it's being multiplied by 4. So 4 times negative 2 over 2 squared, which is 1. And then plus what was being added here, the 6 over 2 squared, which is 3 squared, which is 9, but times 5, because we pulled that 5 out. So 5 times 9, which is 45. Okay, so then we have to get this into factored form. So we have 4 times x minus, now remember, we get whatever we're adding or subtracting here from our b over 2. So this is going to be minus 1 squared plus 5 times y plus 3 squared, and then equals negative 29 plus 4 plus 45. So negative 29 plus 49 is going to be 20, I believe. So here is what we have. Let's put it all together. So 4 times x minus 1 squared plus 5 times y plus 3 squared equals 20. Now, hopefully from here you can tell that this is going to be an ellipse. And the reason we know that is because even though it's equal to 20, some people might say, oh, it could be a circle or an ellipse. Well, one key to that is that the x and the y term, the x minus 1 and the y plus 3, they don't have the same coefficient. Okay, if they had the same coefficient, then it would be a circle. But since they're different, it's not. And I'll show you why here in a minute. So if we, and another reason we know it's an ellipse is because there's a plus in the middle. Because you could think, oh, this looks like a hyperbola. Well, since there's a plus in the middle, that means it's an ellipse. If it wasn't a minus, it would be a hyperbola. So in order to kind of keep going here and figure out that this is an ellipse, you could then divide by the 20 here of everything. So you would get x minus 1 squared, 4 over 20 is 1/5, plus y plus 3 squared over 5 over 20 is 1/4, so over 5 equals 1. So you can clearly see here this is going to be an ellipse because we have an a squared and a b squared. Okay, and that's all it asks you to do is just tell what kind of an equation it is. So basically, if you got a question like this on a test, you could possibly, since this is distance learning, get away with just guessing and thinking, oh, well, this is going to be a plus because these are both positive, essentially. But it might come in handy, especially if you're asked to find then your vertices and foci and all of that, to know how to complete the square. Okay, we aren't going to do that though right now. All right, write the equation in standard form. What conic section does this equation represent? Now, hopefully looking at this, you can maybe kind of see that we are going to end up with a parabola because x is not squared, but y is. So if you have one that's squared, one variable that's squared, one that's not, you know it's going to be a parabola. It is going to, if I know how to spell, parabola, it's an R. If you are asked to write an equation in standard form, though, we're going to go through and complete the square just like we did on the last one. So we have x equals, and what we're going to want to do is kind of keep these y's grouped together and keep this minus 13 separate. And here's where things get a tiny bit different from the last one we saw. So first, we can see we have negative 5y squared minus 20. We're going to factor out that negative 5. So we end up with negative 5 times y squared plus 4y plus, we're going to complete the square, b over 2, so 4 over 2 squared minus 13. Now we added this 4 over 2 squared. And since we're still on the right-hand side of the equal sign, we are going to then subtract that 4 over 2 squared times negative 5, since we pulled out this negative 5. So it's going to be minus negative 5 times 4 over 2 squared, which is 4. Okay. Then we just want to simplify, so we're going to factor this bad boy. So x equals negative 5 times... remember, this is your part of the factor right here. This is your plus b over 2. So y plus 2 squared. And then minus 13, and that's going to be plus 20. So then x equals negative 5, y plus 2 squared. And then that's going to end up being plus 7. Okay, so from here, then you should be able to find your center, your p-value, and then from that find your, not your center, it'd be your vertex for these ones. Your vertex, your p-value, and then from there you'd be able to find the focus and directrix. You don't have to do that right now. We're just finding the standard form of the equation, and it does end up being a parabola. All right, write the equation in standard form. What kind of conic section does this represent? So I'd like you to maybe pause here and see if you can start completing the square with this one on your own. And then if you get to a point where you need to stop or you get stuck, you can kind of play through and make sure you're doing things right. So pause here, give it a try. If you get stuck, hit play again. All right, so what I've done to get this set up, it looks a little different than what we've done in the past. You'll see here I put the y's first, and I put the x's second, whereas normally I always did x first and then y. Take a minute to think about why you think I might have done this. And then I'm going to tell you the reason I did this is because see here how the 9x squared is negative? Really, by now you should look at this and think, oh, this is going to be a hyperbola because this is a minus 9x squared. So it's going to be minus a 9 times x minus or plus something squared. So that's how we know that this is going to actually end up being a hyperbola. Now, if you're asked to find the different parts of this hyperbola, you're going to want to continue completing the square. So let's finish this up. So for our y's, we're going to factor out a 25. And then add b over 2, so 2 over 2 squared. And then we're going to subtract 9 times x squared plus, this is going to be a plus because it's minus 18x, and this is a minus 9 out front, so you want to keep the negative there. So plus 2x plus 2 over 2 squared equals 209. Now we're on the opposite side of the equal sign, so we added 2 over 2 squared, added 2 over 2 squared times their coefficients out front here. So we're going to want to add those to the other side to keep it balanced. We're on opposite sides now, so we're doing the same thing to both sides. So plus 25 times 1 plus negative 9 times 1. So if we factor these out, remember the b over 2 is what we're going to use when we factor. So you end up with 25 times y plus 1 squared minus 9 times x plus 1 squared equals 209 plus 25 minus 9 is 225. And again, you could stop here because you would know then that, yes, this has to be a hyperbola because we're subtracting in the middle there. One term is positive, one term is negative. But in case you had to find other parts of this, remember it would have to be equal to 1. So you're going to want to make sure you divide by 225. And you're going to get y plus 1 squared over 9 minus x plus 1 squared over 25 equals 1. So there's your standard form, and we know this is a hyperbola. We knew it was a hyperbola before we completed the square, but again, this is a skill that you're going to want to have to be able to find the standard form of the equation. All right, another way we can write equations is if you were given what kind of a function it is, what kind of a graph it is, and then given some kind of key points, and then you have to figure out, your A, your B, your center from there, okay? So find the equation of an ellipse with these endpoints, negative 9, 5, negative 3, 5, negative 6, 7, and negative 6, 3. So you can kind of draw around that and see, oh, okay, it's obviously going to be an ellipse. But what you need to find about the ellipse first, since this is not around the origin, you can tell because here's the origin down here, you can tell it's shifted. So basically you just need to figure out what the center is. Now when you're given just 4 points to find the center, basically draw in your minor axis, draw in your major axis, and where those intersect, that's where your center is. So that's why your center is at negative 6, 5. You could also look at the x values of the minor axis and the y values of the major axis, and that would also tell you your center. So that means h is negative 6 and k is 5. Also, we're going to want to remember, okay, this is a bob, so it's wider along the horizontal. So our skeleton of our equation is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now h and k we have, so we know it's going to be x plus 6 squared over a squared plus y minus 5 squared over b squared equals 1. So the next thing we need to do is find what a squared and b squared are. Well, remember a, 2 times that is going to be, if you look at your formula sheet, is the length of the major axis, and 2 times b is the length of the minor axis. So major axis is 2 times a, minor axis is 2 times b. So let's look at our major axis here from -9 to 3. What's the length of that? Well, -9 to -3, that's going to be a difference of 6. So our major axis is 6, so that means A would have to be 3. And then our minor axis goes from 3 to 7, so the length of that is 4. So then B has to be 2. So once you find A and B and you found your H and K from your center, you should be able to fill those in then. So if I just go ahead and erase these. So A is 3, so then A squared is 9. And then B is 2, so B squared is 4. And remember, on ellipses, the x always comes first, and the a squared goes under whichever axis is the longest. So that's why a squared goes under x plus 6. All right, next we're going to write the equation of a hyperbola with center 1, 2, a vertex at 4, 2, and the asymptote y equals 2x. So from this information, you have to figure out what kind of hyperbola is this. Is this a hyperbola that opens up, or is this a hyperbola that opens sideways? So let's kind of look here and see. So our center is here, and our vertex is over to the right of that. Since you have a vertex to the right, that means it's going to open something like that. Okay, we're opening to the right and to the left. Okay, so since we know that, our skeleton for a hyperbola opening right, left with a center not at the origin is going to look like x minus h squared. And it's going to be helpful to have your formula sheet out when you do these. That's why I paused there, because I was looking at it, because let's be honest, even I can't remember this sometimes perfectly well. It's a lot of similar things all at once. So this is what our, because remember a squared always comes first on hyperbolas. So since it's a sideways and not a vertical hyperbola, x minus h is going to come first. All right. So then from here, we just need to know our center. Oh, well, they gave that to us. Our center is 1, 2. So h is 1, k is 2. So we have x minus 1 squared minus y minus 2 squared equals 1. Now we just need to find a and b, so we can find a squared and b squared. Well, remember, a is the distance from the center to your vertices. So our center at 1, 2, we just have to figure out how far away from our vertex is that. Well, from x equals 1 to x equals 4, that's going to be 3. So we know then a has to equal 3, so a squared equals 9. Also remember our slope of our asymptote. So this 2 relates b and a together, because remember, slope of your asymptote for this type of hyperbola is equal to b over a. So if we know the slope of our asymptote here is 2, because y equals 2x, so slope is 2. We don't know b, but we know a is 3, right? So then if we cross multiply here, we get 3 times 2 is 6. So b would have to equal 6. So b squared would equal 36. So since we have a squared and b squared, x minus 1 squared over 9, y minus 2 squared over 36. Now remember, on hyperbolas, a squared isn't bigger than b squared. A squared always comes first. And we know this is opening right and left because a squared is under the x. If it was opening the other way, y minus k squared would come first. So here's our equation for this function. Lastly, write the equation of a parabola. You can kind of see we're doing one of each here. With a vertex, -8, 4, and an axis x equals -8, and passing through -7, 0. So here's a graph with those key points. Now read this carefully. It says this is the axis. So that means this is going through the middle of your parabola. It's going through the vertex. So that should tell you then, since your axis is vertical like this, we're either opening up or opening down. And then they give you this other key point here that it's passing through the point negative 7, 0. Negative 7, 0 is down here. So we know then that our parabola has to open down. So since it's opening down, we know this is going to be a y equals negative 1 over 4p x minus h squared plus k. Your vertex tells you the h and k value. So y equals negative 1 over 4p times x plus h squared plus 4, right? That's left 8, up 4. And now our only thing that we need to do is find p. Now it would be nice if they gave us the equation of the directrix or the point of the focus, because then we could just count and see how far away from the vertex that is. Unfortunately, they don't give us that. What they do give us, which is actually kind of handy, is this point, negative 7, 0. So since that's our point, we're going to use that as x and y to plug in to our equation so that we can solve for p. So y is 0 equals negative 1 over 4p, x is negative 7 plus 8 squared plus 4. So notice now the only variable left is p, so we have to solve for p. So first let's subtract 4 from both sides. So negative 4 equals negative 1 over 4p. Negative 7 plus 8 is 1 squared. Then, okay, 1 squared, negative 1 over 4p times 1 is just going to be negative 1 over 4p. So we have negative 4 equals negative 1 over 4p. Now this is a good sign. Both sides are negative, so really positive 4 equals positive 1 over 4p. So now we know we're not going to get a negative p value, so we're doing something right. And then you're just going to want to cross multiply. So 16p equals 1, so p equals 1/16. So if we plug that into here, let's write our final equation. Y equals negative 1 over 4 times 1/16, x plus 8 squared plus 4. And then from there, this 1 over 4/16, that's a fraction within a fraction. So we're going to write it as the reciprocal. So really this negative 1 over 4/16 is negative 16/4 x plus 8 squared plus 4. So y equals negative 4 x plus 8 squared plus 4. And that is your equation of the parabola. So that went through completing the square and then how to write equations given certain information about ellipses, hyperbolas, and parabolas. So hopefully that touched on things that will help you out. Finish up if you haven't already started 11.4 worksheet day 2, and make sure you get to that daily task on Schoology. Again, I recommend you do the worksheet first, or most of it, and then do the daily task second.